We have another complex number and we are to write its polar form. The given here, z sub 2 is equal to 2 plus twice square root of 3i. It might be different from the previous one as we have here a radical expression, but I'm purposely placed this one here so that we can actually see how it is done if the radian measure would be a special angle. Because we're talking about the polar form in this form. So z sub 2 should be written as r cosine theta plus I sine theta. In short, the angle should be part of it together with r, and the angle here supposedly would turn into a special angle in radian measure, because previously in the previous video we were not able to come up with a special angle. So this time I'm illustrating this example, or we're going to use this example to illustrate a sample of an angle in special angle. Let's start with r. R is actually the modulus of our given complex number. So it's the modulus of, let's say, 2 plus 2 square root of 3i rather, sorry. And then you will have here the square root of 2 squared and 2 square root of 3 here. So basically, you simply need to simplify that. That's 4 plus 4 times 3, which gives us a result of 4 plus 12. That's actually square root of 16. So we have here 4 as our r. This r is the length of the complex number as considered as a point on our Argand plane from our origin. Because if we are going to plot this one, this is actually our x, which corresponds to the vertical, and this value is our y. So our x is 2, 1, 2, or in this case, let me use larger grades. Let me have grade as 1/2. So my 1 is here, my 2 is here, and 2 square root of 3 is approximately 3.46, and so on and so forth. So we have here 1, 2, 3, so almost half somewhere here. Okay, take note that our Argand plane here, or Argand diagram rather, or the complex plane, again, this is our y, this was our x, and we share the same quadrants, and since both of them are positive, we can see the point on our quadrant 1. This is actually again 2 and 2 squared 3. R, as mentioned, is the distance from that complex point to the origin. This is our 4 here. So we are now okay with R. Now let's talk about our angle. The angle is actually formed by moving counterclockwise from the horizontal x-axis towards that segment. So we're looking for this angle here. And how do we do that? We are going to illustrate this by a right triangle here. We know that the height here of this triangle corresponds to your y, and the base is your x, which is 2. So moving that here, approximately we have this figure. Let's make it better. Okay. This is 2 square root of 3. This was 2, and that is 4, right? So we have a right triangle here. So we can now apply the trigonometric ratios to solve for the angle intended for this. This was our angle here. That is our angle here. The theta. Again, should be in radian measure. Now, let us proceed in using sine. Let us use sine so it will be easier for us to look for the appropriate angle if there is. The sine of angle is the opposite of the angle over the hypotenuse. The opposite, this one here, 2 square root of 3 over the hypotenuse, which is 4. And this is simplified to be square root of 3 over 2. Okay, so what would be the value of our theta, the angle, if our sine is square root of 3 over 2? We know this to be a special, a part of a special point, hence we will have a special angle as mentioned in contrast with the previous given video. To move that further, let's take the arc sine of square root of 3 rather over 2, arc sine. Okay, so simply try to solve for the angle. Now, actually, the angle has two values. This is actually pi over 3, and the other one is actually 2 pi over 3. Because when you look at this one here, the same point here, when reflected on the other side, we'd also be having the same angle here, right? This is actually the pi over 3, and this is, the larger one is 2 pi over 3. But since, it's very important also to say this, we know that our complex point is actually on the first quadrant. Now it is the time that we can only assure for the pi over 3 to be the correct answer and not the other one. Okay? Except this one here, because our point is at the first quadrant. That helps us in identifying the radian measure. And as mentioned, this is actually a special angle. So again, in contrast to the previous video. Now that we have our pi, I mean theta, and our r earlier being 4, we can now write the, sorry, not that one, here, the polar form of this complex number. Our complex number z sub 2 is again 2 plus 2 squared of 3i. So in complex, in a rather polar form, r times cosine theta plus I sine theta, which would mean r is again 4 cosine pi over 3 plus I sine pi over 3. Okay, this is now okay to be used for further investigations as we dig deeper on these topics, or you can rewrite this in another form. You have r, sorry, cis theta. This corresponds to the cosine I sine. That would mean this is actually 4 cis pi over 3. This will also be acceptable. This is how we write the polar form of the given complex number, and at the same time, this is an illustration of an exact special angle in radian measure for the theta. We will still have more examples, and it could be varied soon. Thank you very much for watching.